Find a number of different ways in which the 10 letters of the word shopkeeper can be arranged so that all three E's are together. The number of arrangement order is important. Let's look at the word shopkeeper. There are 10 letters. And out of these 10 letters, we have one S, one H, one O, two P's, one K, three E's, and one R. That makes all the 10 letters in the word shopkeeper. To find the number of arrangement so that all the E's are together, we must hold all these three E as one object. So if we are holding this as one object, in total we have 1, 2, 3, 5, 6, 7, 8, 8 objects in total. So to find the number of arrangement of these 8 objects, we have 8 factorial. That 3E is considered one object. So that gives us 8 factorial. But the P's are repeated. There are 2 of them. You have to divide by 2 factorial. And that is 20,160. Part B, find the number of different ways in which the letters of the word shopkeeper can be arranged. So again, order is important so that the P's are not next to each other. The P's are not together. Let's look at the P's. We have 2 P's here. So from these 2 P's, they must not be together. The way to do this question easily is if you're looking at the P's not together, that is given by the total number of ways minus the number of ways where the P's are together. So to find the total number of ways, for this case here, there are 10 letters, we have 10 factorial. There are 2 P's, we divide by 2 factorial. 3 E's, we divide by 3 factorial. In total, the number of arrangement of all these 10 letters is 302,400. And when the P's are together, so when we hold the P's together, this is considered one object. So if this is considered one object, in total we have 3, 4, 5, 6, 7, 8, 9. So we have 9 factorial here. And the E's, there are 3 of them, so we divide by 3 factorial. This will give the number of arrangements where the P's are together. And that is 60,480. So what we want is to find the number of arrangement where the P's are not together. We have 302,400 subtract 60,480. And that will give 241,920. Part C, find the probability. So we are looking at the probability that a randomly chosen arrangement, order is important, has an E at the beginning and an E at the end. So if we have one E at the beginning and one E at the end, so we take out 2, there are another 8 letters here that you need to arrange. So there are 8 letters here. The P's are repeated. So there are two P's here, then in that case, the number of arrangement where there is an E at the beginning and an E at the end, that is 8 factorial. You take away the two E's, there's only one E and P is repeated. So you must divide by 2 factorial. That will give 20,160. To find the probability, so the probability that we need to find would be 20,160, and we have to divide this by the total number of arrangement, which we found in part B just now, and that is 302,400. This will give a value of 1/15. And this is the probability that a randomly chosen arrangement has an E at the beginning and an E at the end. Part D, 4 letters are selected. So if you're talking about selection for part D here, order is not important. We do not consider order. It's just a selection. We need to find the number of different selections if the 4 letters include exactly 1 P. So if you look at this, everything is distinct except the E. So there are 3 E's here. When you're choosing 4, you want exactly 1 P. So you have 1 P, and then it is possible that all these 3 are different. There is no E here. So over here, no E's. And then you could have a P and E, and you do not have any E at all, because take notes, there are 3 E's. You could have a P and E and not an E, or you could have a P and then you have an E and an E. So now, there is only 1 P, we need to discard this. When we discard this, what we are left with is you have 1 S, 1 H, 1 O, 1 K, and 1 R. So you also have the 3 E's here. For this case, we need to find the number of selection of 3 letters out of this. So there are 1, 2, 3, 4, 5 letters here. From 5 letters, we need to select 3. The number of selection would be 5C3, and that has a value of 10. Or we could have the case where you have a P and an E. There's only one way to choose an E out of that 3 E's. They are all the same. These 2 are distinct. From these 5 distinct letters, we need to choose 2 of them. So we have 5C2, which is a 10. If you have 2 E's here, we need to find the number of ways to choose 1 letters out of these 5. We have 5C1, which is 5. There is only one way to have P, E, 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 to choose all these. So we either have the first case, the second case, or the third case, or the fourth case. When you see the word or, you just add all this, and that is 26.